Hello everyone, welcome to Microwave Engineering lecture series. In this lecture, we'll discuss about the transmission lines model. That is, we can see as an general theory of transmission line model. Here you can see the general solution of transmission line model. In last lecture, we have described about the equivalent circuit of transmission line model with respect to two wire concept. So here, in two wire concept, we have taken this two as an reference lines. That is why we have mentioned as a resistance and inductance and resistance and inductance. Now what we do is for analyzing purpose, we'll make this as a ground plane. So thus, so that we can make this line as a reference line. So based on this, we have drawn the equivalent circuit model. Here you can observe this is an voltage. Voltage. There is ES is an input voltage, and then ZR is a load voltage. Similar to this, and we are measuring this current between these two distance as a ds. So we have to find out what is the element voltage drop in between this length of ds, and we are deriving this equation for the infinite line purpose. So this we have taken from the one end to the other end point. So the element voltage drop in the length of equivalence length is ds is dE, that is dE is equal to Iz into ds. Now what we do is we differentiate this equation, so that's why, so this dE and this ds will make, we have to differentiate with respect to ds, so we'll make this to be down, and then this will get off in Iz. Now what is the amount of leakage of this current in this shunt capacitance? That is shunt admittance from one conductor to the other conductor, that is which is given by di is equal to Ey into ds. So this di by ds is equal to this Ey. And now what we do is again the same with respect to ds. We are differentiating this, and we are rearranging this term. So we get this di by ds is equal to Ey. And now we are differentiating this two equation 1 and 2 with respect to of s parameter. Now we get this of d square E by ds square, and now we get z into, from this equation 1 we get z is z into di by ds, and similarly for the equation 2, di by ds is equal to Ey, and again we differentiate this term as also with respect to ds square. So this we differentiate this de term, so that's why we get the de by ds. And now after differentiating, we get the two term of with respect to de and di. That is d square E by ds equals z into di by ds, and we already know this di by ds is nothing but Ey. And similarly for this d square I by ds square, we get the term of y into de by ds after differentiating, and we know this de by ds is nothing but the I sign. So we get these two equation from for the both the function of E and I. And now we do this equation 3 and 4 as an, again we'll go for the differential equation along with this entire length of this line. For example, we have to consider of infinite line from this one end to other end. So we have to consider from the both the end condition. That's why we are taking this entire line as an along the line. So we have to solve this equation, this expression with respect to E and I. So what we do is we make the d by ds term as reference of m. So we make in the form of quadratic equation, that is nothing but we get this of m square minus this, we can d by d square we mentioned as an m square. So we get this term by rearranging this equation. If we consider this an m square, and we make this minus zy into inside the equation, and we make it equal to 0. So we get the term of m is nothing but plus or minus root of zy, and we'll remove this term Ey, which is not equal to 0, and the same result whatever we are getting with respect to for E condition, that is current voltage condition. So similarly we get the condition for the current equation, and we take of m is nothing but we get of plus or minus root of zy, and for this y condition for the current equation we get m is a plus or minus root of the Iz condition, and here we get the two existing solution, and we consider this E and Y should be the positive solution equations. So in this slide we'll discuss about this equations as So here you can see this, we get the two arbitrary equations, that is E is equal to A into e power s into root of zy plus b into e to the power of minus n into root of zy. And similarly in I equation also we get a current equation also we get C is equal to E into e power zy and d into e power minus n into zy. Now this v a b c d we consider as an arbitrary equation. So we use this two equation for calculating the receiving end distance between the receiving end. So for the receiving end kind condition, we will make this after the receiving end, the transmission line, that s will become as in 0. So if we after putting the s is equal to 0 in this equation, so we get this only the after s is 0 means e power 0 is 1. So we get the two arbitrary equation as in e is equal to a plus b and I is equal to c plus d. And we are going to for receiving, we are calculating the receiving end condition. So we make e is equal to er, and I is nothing but current in the receiving end distance. So this e will become as an er and I will become as an ir. So we get the two condition of a plus b, er is equal to a plus b and ir is equal to c plus d. And similarly, we use this equation for and we do the differentiating equation with respect to 6 and 7. So we get this equation of dE by ds, and we do the differentiating equation. So we use this a, and s will come down here, and again e to the power of s into zy. Similarly, this b is also similarly we make this ss, and down we'll get after differentiating. So b into root of minus zy e to the e to the power of zy condition. And similarly we get the same how we differentiate dE by ds. Similarly we get the current equation of also di by ds condition, that is c into root of zy into e to the power of root of zy into s. And so this we know this dE by ds is equal to Iz and di by ds is equal to Ey. So now we substitute these equations into the 6 and 7. So what happens is di by ds is nothing but Iz. So we replace this as an Iz is equal to a into, and we root of zy e to the power of root of zy into s minus b into the root of the power of zy e to the power of minus root by zy s. So similarly, this current equation is also di by ds will replace in the form of Ey, and we get the same, similarly the same term will replace here. So in next lecture series, we'll complete the equation of transmission line model.